Hi guys, so today we're going to start solving systems of equations. There's 3 different ways we can do this, but for now we're just going to focus on solving by graphing. So a system of equations is 2 or more equations and we want to find the solution. So the solution is the ordered pair or pairs that make both equations true, meaning that like if the first equation you get 7 on this side, you have to get 7 on that side. So we want to find the ordered pair that makes both of them have both sides equal to each other. So on a graph, it's the intersection of your lines. So we talked about when we were graphing how that line is all the solutions. So if we have 2 lines, that intersection is where they're both true. So in order to find this out, we're going to convert both equations into slope-intercept form and then graph them and find our intersection. Now we can have different types of solutions. So one solution is that the lines intersect. So I just drew this one, so that means our solution is right there, and we only have one solution. Sometimes we can have no solutions. If both of our lines are parallel to each other, they will never meet, so we're never going to find a point that makes both of them true. And then infinite solutions is where they are both the same line. So every single point on that line makes both equations true. So for example, if we look at y equals 3 over 2x minus 4 and y equals negative 2x plus 3, we're going to graph both of them. So this first one they're already in slope-intercept form. So if we take a look at this one, we're going to start at negative 4. And then we're going to count up 3 and over 2. And you can keep going because we're going to need to find the point where they intersect. And we can go the other way. We can keep going further after if we need to. And then for the other one, we have y equals negative 2x plus 3. So I'm at positive 3. I'm going to go down 2 over 1, down 2 over 1. That's the point where they meet, right here. So my solution is 2, negative 1, where that point is. So let's look at another example. These are also both in slope-intercept form already. So my first one is y equals x minus 1. I'm going to start at negative 1. And then we go up 1 over 1, so our line looks something like that. And then for y equals x plus 4, I'm going to start at positive 4. And my slope is up 1 over 1. Well, if you notice, these lines have the same slope. They are parallel lines, so this is when we would have no solution. They will never meet. This last one, the first one is in slope-intercept form, so I'm going to go ahead and graph that one. We have y equals negative 2x plus 3. So I'm going to count down 2 and over 1, and so on. We can always go back and add more points if we need to. This one, I need to make it be in slope-intercept form, so I'm going to subtract my x term, this 2x, from both sides. So we have y equals negative 2x plus 3, and now I can graph it. But oh look, it's the same exact equation. So this is where we get infinite solutions. So we're going to work on this more tomorrow in class, so come to class with any questions.